I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on projectile motion. Today we're going to look at 2D kinematics, projectile motion. What is a projectile? We can see here Ryan Krauser's throwing a projectile, throwing a shot put that launches through the air. So it's anything that's launched or hurled near the Earth's surface. Making it a little simpler, let's look at a racquetball rolling off of the table. And we can slow that down and mark its position at multiple points in time and see that it takes a path that's kind of a parabola shape, which is called a parabolic trajectory. Now, if we can look at the data that we get from this and plot a position versus time graph for the vertical direction, we can see that the slope of this curve is getting steeper and steeper, which tells us that the speed is increasing in the vertical direction. If we look at this from the x direction standpoint, we can see that this graph shows a straight line. And what does that mean? Well, that means that the velocity is constant in the x direction. Now looking at a bowling ball rolling off of the table. The bowling ball takes the same parabolic trajectory from the table to the floor, taking about the same time that it takes the same number of frames to get to the floor. So it means it takes the same time to reach the floor. So the mass does not matter. A racquetball versus a bowling ball takes the same time. And looking at the data for the position, the vertical position time, we get this same curve with the same increasing slope, which means the velocity is increasing again in the vertical direction. In the horizontal direction, we get the same graph showing the horizontal motion is still a constant speed, regardless of how heavy the object is. So whether it's a racquetball or a bowling ball, does not matter. So looking at the horizontal motion, here's the graph that represents the horizontal motion for the bowling ball. The bowling ball moved at a constant speed as shown by the slope of the graph. Remember, slope of position time graph is velocity, and the velocity doesn't change because the slope doesn't change. If we looked at a cannonball being launched that was not affected by gravity, it's shot and it's launched and it moves horizontally, and it would not stop until it hits something. It would continue at that constant speed until it hit something. So what do we know about the motion in the horizontal direction? Well, it's constant. It's not accelerated, it's not influenced by gravity, and it follows the equation, the second kinematic equation on the AP Physics 1 formula sheet, which is the x equals equation. And we know that the x direction acceleration is 0, so it simplifies that equation down to this for us. Now let's look at the vertical direction. The vertical direction has this curve, which is a curve that shows that the tangent line slopes are getting steeper. Well, with the tangent lines getting steeper, what that tells us is that the speed is increasing. The slope's getting steeper and steeper as time goes on, means that the y direction is speeding up. If we looked at the cannonball only moving in the vertical direction, we'd see the cannonball is in free fall. And in free fall, we learned from a previous video that the acceleration is 9.8 meters per second squared downward. So that means in the y direction, we have a free fall situation. It undergoes accelerated motion. That acceleration is 9.8 meters per second squared downward, and it follows all three kinematic equations, where AY is equal to 9.8 meters per second squared downward. Let's look at both of those motions together. So if we shot a cannonball and they moved together horizontally and vertically, constant in the horizontal and vertical is in free fall, we launch that cannonball, we look at its path and line it up with the horizontal and vertical motion. We have the gravity independent path, which is the horizontal path that it takes. And we also have the free fall path, which is the vertical motion. And combining those two together, we get the path of a projectile. A projectile's path is a parabola, or half of a parabola, in this case being launched horizontally. This is Introduction to 2D Kinematics and Projectile Motion. I hope this was helpful. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.